Problem 2 wants us to take the same function over the same interval, but now use n subintervals. So now we're going to generalize this. Instead of using 100, we're going to just do it in terms of n. So the width is b minus a over n. So the width of each rectangle is 3 over n. So now if I write down a couple of the subintervals, I can see that the left side of my first rectangle will be 0 because that's where we start, and the right side will be at 3 over n because they're only 3 over n wide. Then the next rectangle will go from x equals 3 over n to 6 over n, and we can kind of see the same pattern emerging. And I want the last number to be 3, so we can see it's going to stop at 3n over 3, so this will be 3n minus 1 over n. So whatever value n I have, we can see that this stops at 3, and this last guy stops at left. So you can see if we tried to use left endpoints, this is why we say this gets a little bit nuts, but we can see the right endpoints actually work out quite nicely. So now if I just look at the pattern of the right endpoints, right, it's just 3k over n. Because if I plug k as 1, I start at 3n, k is 2, 6n, and so forth. So now I'm going to calculate f of ck. So I plug 3k over n into my function, and I get 9 over n squared times k squared. So those represent the heights of any individual rectangle. To get the area in terms of n, we're going to sum up from k equals 1 to n of delta x times f of ck. Sorry, that's supposed to be an x. So delta x is 3 over n. And f sub k is 9 over n squared times k squared. So I'm going to pull my constants out front, and I'm going to have 27 over n cubed times the sum from k is 1 to n of k squared. So I have a formula for this. So 27 over n cubed is going to be times n plus 1 times 2n plus 1 all over 6. And usually we want to simplify this down as far as we can. So 6 is divisible by 3, and 27 is divisible by 3. So if I divide each of these by 3, right, I'm going to get 9 halves. Then I can cancel one of these ends with one of these ends and get n squared. So now I can say I have 9 times n plus 1 times 2n plus 1 all over 2n squared. So this is the estimate. So notice here when it just says estimate, you stop at s sub n.